few people ask me about some of the geometric formulas and how to use them when you're asked to give exact values. That means leave the radicals, leave the pi, things of that nature. So let's look at this question. We have this right pyramid with a regular hexagon. And we know that the length of the sides is 6 meters. So that means that each of these sides, and I'm going to get a different color, is 6 meters. So we have the 6 meters. So what this tells me, first of all, is that the perimeter of this hexagon is going to be 6 times 6, or 36 meters. And we're going to need to know that for that surface area. Now, we also are going to need to know the area of this hexagon. And the area of this hexagon, or the area of our base, is 1/2 the apothem times the perimeter. Now, the apothem is this, what we consider the radius going from the center of one of our sides to the center of our figure. It's not going from one of the corners, but actually from the center here. And so one of the things about a regular hexagon that we also know is that on a regular hexagon, these sides are all equal to each other. So whenever I form this triangle here, I know that all of these sides are actually equal to each other. And so I know that this side is 6, this side is 6, and this side is 6. But I don't know what this is. But I can use the Pythagorean theorem, a squared plus b squared is equal to c squared, to find out this measurement. Because I know what c is. That's the hypotenuse, it's 6. And so I can put it over here. And I actually know what one of my sides here is. This one side, which is this right here, is 1/2 of this value. So from here to here is going to be 3. So I have 3 squared. And so I'm going to solve for that apothem. And so 3 squared is 9. 6 squared is 36. And so I'm going to subtract the 9 from both sides. I get 27. And then to get rid of the square, I take the square root of both sides. And so here we have a number that is not a perfect square. And we need to break it down. And if you put it in your calculator, you're going to get this decimal number. Well, you want the exact value. So what happens is we break this down and to values that multiply to give me 27. Well, two numbers that multiply to give me 27 are 3 times 9. And then we look at it and we say, oh, well, the square root of 9 is 3. So I take out the 3 from the square root of 9. Okay? And then I put the other 3 that is left over underneath the radical. Another way to look at this is 27 is 3 times 3 times 3. I have a pair of 3's, we call it the buddy system. The buddies come out as a group, and whatever does not have a buddy has to stay home underneath the radical. And that's how we break up the radicals. Okay? So now I have my apothem. We need the apothem in order to find this slant value here, because the apothem is this length here. Okay? Well, our problem gave us that the altitude was 3. So that meant that this side is 3. Now we know that this is 3 square root of 3. We need to find the slant of our pyramid. And we're going to use the apothem also to find the base here in just a few moments. I did not forget that we haven't found the actual area of the base yet. I'm trying to find all of our sides at the moment. Our slant is using L. And so that is now our hypotenuse. And so we're going to use Pythagorean theorem again, which if I use Pythagorean theorem on that, a squared plus b squared equals c squared, which in our case is actually our L, we're going to get 3 squared plus 3 square root of 3 squared is equal to c squared. Now if you recall, 3 square root of 3 was the same thing as the square root of 27. If I put that back together, c squared and 3 squared is 9. This square and this square root are going to cancel each other out, leaving me with 27. And then 9 plus 27 gives me 36. And the square root of 36, because I have to take the square root of both sides. So my slant height is going to be 6 meters. My apothem is 3 square root of 3 meters. Now the reason why we needed to find all of this is the area of the base is going to be equal to 1/2 the apothem times the perimeter. So that's 1/2 times 3 square root of 3 times the perimeter, which we determined was 36, because we take 6, our length of our side, times how many sides we have, which is 6. When we multiply this together, 1/2 times 3 times 36, notice I did not include that square root of 3. I'm just including whatever is outside the radical. I get 54, and I'm just going to leave that radical sitting underneath, out there. So the area of my base is 54 meters squared. The area of the pyramid sides, each side of the pyramid, is going to be, so for the sides, is equal to 1/2 the perimeter times the height of the slant. So we get 1/2 times 36 times the height of the slant, which was 6. 1/2 times the 36 times the 6 gives me 108 meters squared. So our total surface area is these two things added together, 108 plus 54 square root of 3. We cannot combine these because one of them has a square root, the other one does not, meters squared. So whenever it asks for the exact values, whenever you have square roots, you basically break them down into their prime numbers and take out whatever has pairs and then leave whatever has individuals underneath the radical. Okay, let me know if you have any more questions.